So, hi, I'm Brent Imhoff. This is Scott Poretsky. And so we're talking about BGP negative testing. So, how do I make this go?
Page down. No,
there
you go.
All right, cool. So, we've had code bugs for forever. We will continue to have code bugs, even back as far as 1996. The best way to find these bugs, though, is typically in test, or the most convenient places to find it is in test. You'd rather find it there than in production. And anyway, some of the ways, the reasons you would want to test for negative BGP conditions for multi-vendor. So if you have a Cisco and a Cisco, operability may work fairly well, but if you have a Juniper and a Cisco, say, you want to make sure that the Juniper does something that the Cisco is going to be able to handle it in a way that it doesn't impact you negatively. Excuse me. Yeah, come do this. Sorry.
You all right?
No.
Oh, okay. Hi, I'm Scott, co-presenting here with Brent. So, negative BGP conditions that we have observed in networks are update message errors. Something as simple as an error in an update message error even causing a crash in a router. Of course, we have BGP route explosion, which can result in out-of-memory conditions, and that may, in fact, cause a router to reboot. And then we've all observed extensive BGP processing where we see high CPU utilization under certain conditions, particularly around BGP session and route flapping. Another thing we've seen is incorrect BGP path selection process. Maybe not so much a bug in a vendor's implementation, but just by the fact that the selection process is now so complex that whether you have a 10-step process, 11-step, 12-step, 13-step, 14-step process is dependent upon which vendor you have and which version of software you have at any given time. So you could have different routers, in fact, calculating a different path selection process. And then also a hardware problem that's been observed in routers is stuck routes, where routes don't get cleared from the ASIC at the interface, and the forwarding table is incorrect. So those are a lot of negative conditions that occur in a network. We want to ensure that routers deployed in a network do not exhibit catastrophic conditions, and even better, are able to handle those conditions properly so BGP can continue along happily. So to do that, we want to do BGP negative testing. Negative testing is the kind of testing in which you ensure that under errored conditions, the networking device does respond properly. It's a lot different from typical testing. It's more difficult from functionality testing, conformance testing, and even interoperability testing, because negative testing is really boundless. The amount of error conditions that you can have with a routing protocol, really you could just continue to list them forever. But in the case of functionality conformance, you have an RFC with a definitive amount of things that should go right. So negative testing is in fact more difficult. So around this came a great question as far back as 2000 on the NANOG mailing list. It was entitled BGP Testing, ? Does anyone have a script or a series thereof to do large-scale BGP testing? I'm looking for something that will generate and nail down several hundred networks for varying sizes, and or fake pairing relationships with similar purpose, and or do things that don't meet the BGP protocol standard. So Tim Brown, I don't know you, but back in 2000 you showed a lot of vision. So where do we go if we want to do that kind of negative testing? The first place one would look to is the IETF Benchmarking Methodology Working Group. That's the IETF's working group in the operations area. that defines, that develops standards for router and switch testing. However, the BMWG really focuses on scaling, forwarding performance, and convergence types issues. There's no standardization of negative testing going on now. Typical RFCs and works that you'll see in the BMWG is the FIB-based router performance, which is RFC 3222, benchmarking of BGP device convergence in the control plane, which is an official internet draft, benchmarking terminology and methodology for IGP data plane convergence, also an official work item of the BMWG. In fact, Brent and I are co-authors on that one. So there is work being done around routing protocols, testing of it within the IETF. However, there is no work being done around negative testing. So that's really getting to the purpose of this presentation, where we wanted to help define what should be done for BGP negative testing, given those negative conditions that can occur in networks and in fact do. So starting with update errors, when you do negative testing with BGP, you want to do bad things with your AS path list when you're doing testing. You want to create routing loops in the AS path list. You want to do testing with the maximum AS path length, first determining in fact what that maximum length is. You want to send update messages with missing, incorrect, errored attributes. You want to do this for different types of peering sessions, eBGP, iBGP, route reflectors, confederations if you're using those. So you really want to mess around with the update packet. It is possible you may have a implementation in your network that does something incorrectly with an attribute, and a neighboring router doesn't know how to handle that. There's been a known case where that neighboring router crashes. Okay, so negative tests like that should be done. You want to do testing in your update message where the NLRI next hop is incorrect. You want to have the receiving router be the next hop for that NLRI. You want the NLRI, in fact, to be its own next hop. And you want to have, of course, an unreachable next hop. Make sure the device under test can handle all of those negative conditions. And then you also want to do interoperability with negotiated capabilities. And you want attributes to be in the update message that should in fact not be there because they weren't agreed upon in the negotiation. Negative testing of BGP resources. I really consider this the cornerstone of the BGP negative testing. You want to maximize memory utilization and CPU utilization and see how your BGP speaking device performs. So first, with out of memory, simulating a BGP route explosion case in your network, you force that out of memory condition by advertising NLRIs until there is no memory available. So you do need to observe the memory utilization on the device. And then you want to continue to advertise so that you go beyond that point. This is a good test because different implementations handle the out of memory condition differently. There are implementations that purposely crash and reboot your router. There are implementations that bring down pairing sessions from which the most routes are being learned. There are implementations where it just hits that point of maximum memory utilization and stops learning routes, period. So there are different ways that different implementations handle this case, none of which is standardized. So you do want to do this negative testing and see how your router handles this. Then there's the case of BGP processing. This is where you force high CPU utilization and see how your router handles that. The two classic cases for the high CPU utilization, two classic test cases, are first one, remove that eBGP pair from which you've learned the most routes in your FIB. Just take that away. That'll force high CPU utilization. That pair from whom you've learned, say, even as high as 100,000 routes, remove it, see how your router handles that case. The next one is what I call the nested convergence event, where you force a convergence event, and while the device is still converging, force another convergence event. So on one link, you may bring that link down, and on another interface, remove the BGP pairing session. So you have these nested convergence events. That will cause a very high CPU utilization. And then there's the case of redistributing BGP into your IGP. That's a very good negative case to see how your router can handle memory conditions. Okay, so now in the convergence test cases, where you have, it's a rather simple setup, straightforward. There are a lot of different conditions for which you want to do this. So you have your device under test, and you have your test equipment. Your test equipment forwards traffic in on one interface, and the DUT has, device under test has two interfaces outbound that are your options. There's the preferred egress interface and the next best egress interface. You want to cause a convergence event to occur so that the traffic coming inbound, going outbound, switches from the preferred to the next best egress interface. And you want to measure the time that this takes to happen. And you want to do it under a variety of negative conditions because you will get different results for each of these conditions. There's cases of link failure where you have local interface failure, neighbor interface failure, even a remote interface failure. Layer 2 failure, so your physical link is still up, but you lose PPP, gig E may go down. IGP adjacency failure, so you have likely IGP next hops for your BGP routes, and that adjacency goes down. You want to cause route withdrawals to force the convergence, and then do a cost change for your IGP or even a med change for your BGP routes to force the convergence events. It really is important to run through all of these cases because you can get different results for each of these cases. Okay, and then there's BGP functionality. There's the path decision process. You want to go through the process so that you advertise the same NLRI from multiple simulated neighbors and force ties so that you walk through each of the steps in the process and make sure that each of those steps is handled correctly. Then you also want to do negative testing with invalid peering. You want to ensure your device will not pair when it should not pair. So you want to do incorrect AS numbers, you want to do MD5 authentication, and you want to do it with invalid passwords and keys, different combinations of that. Make sure your device does not pair. Okay, and then there's particular BGP configuration that really can influence the performance of your BGP speaking device. The first one is your hello keep alive timer. You can have it set to 30, 90 seconds or 60, 180. With different implementations, you can really notice difference per, excuse me, I think what you have is contagious. Yeah. So different, different implementations will actually have different performance, especially around the area of CPU utilization with that hello keep alive timer being set. So you may in fact want to set it lower to 3090 from 6080 and see what the performance hit is that you actually get. Another configuration, and this one comes more from your test equipment, is the update rate. Routers are typically stable learning 2,000 NLRIs per second. However, if it gets much higher than that, you can see sessions start to come down. So you want to do negative testing. And test equipment now can even go as high as 5,000 NLRIs per second. You want to set the test equipment to that and ensure that you can handle that case if you're getting flooded with too many NLRIs quickly. Now, in combination with hello, keep alive timer, and update rate, your results for CPU utilization, memory utilization, can be impacted by the number of peers you have established, what types of peers those are, the number of routes you've learned from each peer, and the total number of routes in your FIB. So you have your RIBs and your FIB, number of sessions. Those can also influence your CPU utilization and memory utilization. So you want to test with various scaling. To improve performance with various scaling, you configure peer groups. That way you're sharing memory resources. So you want to do testing with peer groups to in fact notice the savings that you expect to get in your router. Okay, so we started to talk about the test tools. Test tools for BGP negative testing really have come a long way in the last year. If there are any test equipment vendors out here, I personally want to thank you for the improvements that have been made over the last year for doing BGP negative testing. You now have the ability to do iBGP or eBGP capability while configuring an IGP, OSPF or ISIS or even RIP if you want, on that same test port, and force your BGP routes being advertised to use those advertised IGP routes as the next hop. So you really, from your test equipment, can get the relationship between your BGP and IGP on the same interfaces. You have the ability to configure update rates and timers to test the various combinations that we just talked about. Another nice feature that a couple of the test equipment vendors have come up with is you can load an external route table For example, show IP BGP. I know, in fact, not showing vendor favoritism in any way, believe me. I know that the Cisco show IP BGP format, that output is supported by test equipment where you load a file with that show IP BGP format of your BGP route table, 120,000 routes. Those are the routes that the BGP session will use in advertising its NLRIs when emulating the BGP session. So that's a very nice feature. So you can do your testing with the actual route table. Okay? And also now, all the test equipment vendors are supporting tickle scripting of their routing protocols. So you can really do some nice automated testing of these negative test cases. In fact, I'd really like to see the test equipment vendors come up with a suite of negative tests so we don't have to go write our own. If we have to go write our own, we're wasting resources, right? If the test equipment vendors could write it for us and we'll just go pay some small price for it, then we'd be willing to, we'd be very eager to have that. All right, and of course we'd like something canned for the path selection process as well. In case you don't want to go the route of buying anything, there are a couple freeware tools out there. There's the Python routing toolkit from Sprint that you can use to emulate a large BGP topology and do some negative testing. And then there's BGP Sim from Merit that's now on sourceforge.com. So those are a couple low-cost alternatives you can use for your BGP negative testing. All right, so in summary, negative testing is very critical, especially for BGP. We've seen what's happened in networks under negative conditions, so we need to do negative testing in the lab before deployment. Make sure your negative testing is driving high memory and CPU utilization. And since the BMWG really hasn't given us anything to grab onto as far as negative testing, we've outlined some key areas where we should do the negative testing. Update message errors, route convergence, path selection process, pairing errors, and then configuration details as well. What Brent and I would like to do at this point is we'd like to bring this as a draft to the BMWG, and even though it's not negative testing is not part of the charter, we think that this is important enough that maybe it does get looked at. Since the BMWG is part of the operations area, your input there, your involvement on all of the BMWG drafts would be very much appreciated. Okay, and then of course for all this testing that we're doing, I think the test equipment we need to get it done is there now. All right, so thank you. Any questions?
Thank you very much. Any questions? Okay, well, you're coming up. I have one. Have you seen anybody doing or having the short enough wit and enough gonadal fortitude to actually test live routers in the wild?
No, and I think that's a good thing.
Can I test yours?
Hi, I'm Tim Brown. Thanks for mentioning me in your presentation.
Oh, hey, nice to meet you.
Just a couple really quick comments and questions. I think first the challenge is a lot of the vendors that are out there and a lot of the operators are out there have written these in-house tools. I get a lot of private responses when I wrote that post, and I think there's a call for operators to try to release some of the in-house tools that they design, because it often meets a lot of these needs that we talk about here at NANOG. The second thing is, I think there's been a lot of advancement in the open source routing community, Quagga, Zebra, et cetera, and those have been real enablers as far as, doing these statistics and stuff. And I mean, I think that, if any of the folks that are contributing to those projects are listening, the statistics side is really, I think, one of the primary things that interests operators, because generally operators aren't running their networks on PC routers and things like that. But the statistics side is definitely a help to us. So.
Yeah, absolutely.
Thank you.
Yeah, thanks for the comments.
If there's nothing else, thank you very much, guys.
All right, thank you.